In this last section of notes, what we're going to look at is how to apply all of our logarithmic and exponential solving skills to some application problems that typically come in the form of financial models and uninhibited growth. So the first thing when you're working through these problems that you need to recognize is the various terms of how often interest is compounded. So interest could be compounded annually, once a year, semi-annually, twice a year, quarterly, 4 times a year, monthly, 12 times a year, daily is 365 times a year, even if we know that that year is a leap year. In the business world, they ignore the leap years and consider 365 days as the number of days in every year. There will often also be problems where they talk about interest being compounded continuously, and for a continuously compounded problem, we will just use E as our number of times, as you'll see in our formulas below. The first thing we want to look at is simple interest. So if we just want to calculate interest for an individual time period, we would use this simple interest formula. Simple interest, again, only calculates the value of an account at the end of a particular period of time. Slide this up. These formulas will not be provided to you, and you do need to not only know the formula, but you also need to know what each part of them stands for. The I is going to calculate our interest. P is our beginning amount, or is often referred to as the present value. R is going to be our rate. We have to remember to convert that properly to a decimal. And T is our time, that is usually in years or a portion of a year. So diving into our first example, we have a credit union that pays interest at 8% per year, and it says that it's compounded quarterly. So from up above, we recognize that this is 4 times a year. Now, assume we invest our $1,000 and we want to find the balance in the account at the end of each quarter, which is how often they're going to be calculating their interest. So if we want to calculate our interest using our simple interest formula, we simply plug into our formula. We're investing $1,000. Our rate is that 8%, but we remember to convert that to a decimal. And then the time on this gets a little bit tricky. We have to remember that we're calculating it after a single quarter, which would be 1/4 of the year. Simply typing that in our calculator, what that gives us is the interest that was earned at the end for that period, but it doesn't tell us the total balance. We need to add that to the initial amount to actually get our true balance. So our final balance would be $1,020. Using our new balance, we can then go on to the second quarter and determine how much interest would be earned in the second quarter. The important thing to understand with compounded interest is that that means that you're going to earn interest not just on the $1,000 that you invested, but also on the $20 of interest that they paid you. So we're going to use this new balance in our next formula. So our interest will become, our new balance is $1,020, still being paid at a rate of 8%. And again, we're only looking at 1/4 of the year. Type that in our calculator. The interest for our new period is $20.40. So our balance at the end of the second quarter is $1,040.40. Each time they want to calculate interest, they would have to go through this process. Now that can be a very time-consuming process to calculate it at the end of each quarter. So mathematicians have developed more advanced formulas to calculate interest just a single time that would cover multiple interest periods. In this formula, again, this will not be provided for you. The left-hand side, the A, stands for our ending amount, but is also often referred to as the future value. P is our beginning amount, as I said earlier. That's often referred to as our present value. N has to match in both places, and that will be the number of times each year that the interest is calculated, and those are just referencing the values from up at the top of the page. And R is going to be our rate as a decimal. Again, if the interest says that it's being compounded continuously, we will use this formula that is often referred to as PERT. Because if you look at the right-hand side, that's exactly what it spells, is PERT. So jumping into the same problem as before, but this time we still have the 8%. We still have compounded quarterly that we know is 4 times a year. And we're still investing $1,000, but this time we want to know the value at the end of 3 years. If we were only using our simple interest formula, we would have to go through that calculation for each and every quarter for all 3 years, which would be really time consuming. So instead, we can simply use our formula from above. We know that our beginning amount is $1,000. We know that our rate as a decimal is going to be 0.08. We know since it's compounded quarterly, we're going to divide that rate by 4. It converts our annual rate to a quarterly rate. That's what this portion does. And then we need to figure out how many times over the 3-year period are we going to calculate interest. So it's 4 times every year for the entire 3 years, so that makes sense that our exponent would be 12. Now, this problem, all we have to do is type it into our calculator. When I type this in, I rarely would type this entire problem in all at once. I start on the inside. I would start with the 0.08. I would divide it by 4. I would add the 1. Now I have the entire expression in the parentheses. I would raise that to my exponent. This one is easy enough done in my head, but it's not always. But I can do that as a 12. Now I take that entire value times my 1,000. Since we're working with money, we're going to round to 2 decimal places. So $1,268.24.